Hello, Pre-Calc. We are going to finish the examples from 4.7, and this first set of examples is going to be a bit of a mini review from yesterday, but then also adding another layer. So it says evaluate without a calculator, sine inverse of sine of 7 pi over 4. Now our first inclination might be to say, well, I know that f composed with f inverse and f inverse composed with f of x are just equal to x, or whatever's inside. The thing that's tricky, though, is the fact that 7 pi over 4 is not in the domain of sine, of the restricted domain of sine, thus the range of inverse sine. So how can we do a problem like this? Well, we're going to go back to the rules that we know and love from just algebra. I'm talking order of operations. We are going to start with inside first. So what is sine of 7 pi over 4? Well, I look at my unit circle. 7 pi over 4 is right here. Sine is y. Sine of 7 pi over 4 is negative square root of 2 over 2. Then I ask myself, what is sine inverse? And I'm at this same spot, right? Because sine is from negative pi over 2 to positive pi over 2. Pi over 2, negative pi over 2. So I know I'm at 7 pi over 4, but because of this restricted domain, I cannot name it as 7 pi over 4. I cannot go past this point, so I need to name it in the opposite direction. Instead of positive 7 pi over 4, our solution is negative pi over 4. Take a moment, if you want, pause the video to try and evaluate the second on your own. Otherwise, you can listen to me explain it. I am going to first, really briefly, erase the work for that last one. So our next problem is inverse cosine of sine of pi over 3. I'm going to start with the inside. Sine of pi over 3. Here's pi over 3. Sine is y. We have cosine inverse of square root of 3 over 2. Sine is y, cosine is x. Now we're asked, where is cosine equal to square root of 3 over 2? Sine is y, cosine is x. Where is my x value equal to square root of 3 over 2? That is at pi over 6. Realistically, these problems are doing the same things we did yesterday. They were just adding an extra layer. We have another example in this section, and it asks us to find an algebraic expression to equal the following. Cotangent of arc cosine of x. The first thing I want to point out is that our answer is not going to be a number. It's not going to be a value. It'll be an algebraic expression, meaning it'll be something in terms of x. Second thing I want to point out is we, just like in the last problems, need to start with this first. We need to figure out what is inverse cosine of x. And so I'm going to go off to the side just for a second to make sure we understand what is going on. If we think about another example, inverse cosine of square root of 2 over 2. Well, where is cosine equal to square root of 2 over 2? That would be at pi over 4. Another way of saying this, or the piece I want us to see, is that arc cosine, inverse cosine, arc cosine, oh wait, no, that was right. Arc cosine of x of some value is equal to an angle measure, right? Pi over 4 is an angle measure. So technically, what I could do in this problem is say, we are looking for cotangent of some angle. Now, the piece that we need to figure out is what angle. And they don't give us any way to find this. So instead of calculating it, we are going to sketch a picture to help us out. Specifically, we're going to draw a triangle. A right triangle, where we have theta right here. We are deciding that this angle and this angle are the same. The only information we know is that inverse cosine of x is equal to theta. Another thing we could remember, though, is that inverse cosine switches x and y for cosine. which means if I wanted to find cosine of pi over 4, I would get square root of 2 over 2, or cosine of angle theta is equal to x. Notice how all I did here was switch my x and my y, just like we do right here. Now we have a right triangle, we have cosine, and we can add to our picture. Using right triangle trig, SOHCAHTOA, we know that cosine of this angle theta is equal to x. We also know that cosine is adjacent over hypotenuse. I can put a 1 in the denominator, and I can label my triangle as adjacent x hypotenuse 1. If I have two sides of a right triangle, I'm able to find the third using the Pythagorean theorem. I don't know what this side is, so I'm going to just put question marks right now. X squared plus whatever that side is squared is equal to 1 squared. I want to figure out what these are, so I'm going to move x squared over. X squared over, I get 1 minus x squared. And then if I want to solve for those question marks, I'm going to take the square root of both sides. So we have the square root of 1 minus x squared as our opposite side. This is now my triangle that I can use to evaluate cotangent of that angle. I now have a problem that is really just right triangle trig. Specifically, if we think back to right triangle trig, cotangent is the reciprocal of tangent. Tangent is equal to TOA, opposite, over adjacent, which means cotangent will be equal to adjacent over opposite. If I want to find cotangent of the angle in this triangle, I'm going to take the adjacent, which is x, and divide it by the opposite, which is the square root of 1 minus x squared. This is an okay answer, but of course we do like to rationalize, meaning I would take both pieces and multiply them by the square root of 1 minus x squared. X square root of 1 minus x squared all over 1 minus x squared. This is my expression, my algebraic expression, and my solution. What we just did was draw a picture to represent this, the inside, and then use that picture to evaluate cotangent of this angle. There is, I believe, at least 1 or 2 problems on the homework like this, so try them out with your classmates if you can at some point. Have a great rest of your day.